Assalamualaikum warahmatullahi wabarakatuh. So today I am Nur Kamilah binti Mohd Nordin and I'm going to present on the evaluation of plant growth regulator induced orthosiphon Stamineus extracts for silver nanoparticle synthesis. Currently I am under the supervision of Dr. Azman Abdul Samad and my co-supervisors are Associate Prof. Nik Ahmad Nizam bin Malik and Dr. Wan Rosmi Zazana binti Wan Dagang. Okay, so first and foremost, I would like to introduce to you my choice of plant, which is Orthosiphon Stamineus, which is also known as misai kucing. It has several biological properties such as antioxidant, anti-proliferative, antihypertensive, and anti-inflammatory. This is due to the presence of phytochemicals such as phenacetin, eupythyrin, rosmarinic acid, and uracilic acid. Okay, next is I'll explain on in vitro culture. So, by definition, it is the in vitro aseptic culture of cells, tissues, organs, or whole plant under controlled nutritional and environmental conditions, often to produce the clones of mother plant. Okay, so for the history, uh, in 1756, Duhamel, who grew callus or calli. Callus is a mass of undifferentiated cells, and in 1902, Haberland established the totipotency concept, who is also known as the father of plant tissue culture. So the advantages of in vitro culture: it improves crop varieties, it produces disease-free plants, also very vital in genetic transformation. It increases secondary metabolites, and it is also very tolerant to salinity, drought, and heat stresses. And it can be used in pharmaceutical and agriculture. Okay, so in order to increase the biomass of in vitro culture, plant growth regulators are used, and normally auxin and cytokinin are used. Okay, as for the uses of PGR, there are several research done by several researchers. As for the example, for the first one, Orthosiphon Stamineus, which is used by Yakub to induce callus cultures by using IAA and kinetin to find the correlation between the callus colors with their antioxidant capacity and bioactive constituents. And for Phyllanthus glaucus and Passiflora fibrosa, which are used to proliferate shoot culture and root by BAP and IAA and BAP and NAA respectively. Okay, so for my problem statement for this experiment, field-grown plants are very slow. It hampers the fulfillment of the high demand for Orthosiphon Stamineus extract. It has different contents of phytochemicals due to geographical and seasonal constraints, and it may take months to years to reach the desired phytochemicals, making them difficult for commercial purpose. And plant tissue cultures are very useful tools to scale up process of any desired plant species. It provides disease-free plants, and it can grow in a large scale in a very short time. However, there is a lack of information regarding PGR's induction and antioxidant activities, and non-reported effects of manipulated PGR's use, especially BAP, that have shown the content of antioxidant in vitro Orthosiphon Stamineus. Okay, so what is the significance of my study? The first one is the optimum BAP concentration for shoot biomass of Orthosiphon Stamineus, and the second one is the enhancement of antioxidant activities through FRAP and DPPH assays, through manipulation of BAP in the range of 1 to 4 mg per liter for the concentration. And the third one is the optimum BAP concentration for both shoot biomass and antioxidant activities. Okay, for the research gap, I am comparing the field-grown and in vitro culture. As for the extraction method, we have both aqueous extract are used, and for antioxidant, for field-grown culture, the assays use ORAC and AAPH, and there is no there is no report yet on in vitro culture. And as for the PGR, for in vitro, Yaqub and Muhammad Nawi and Abdul Samad have reported in the use of carnitine, IAA, and BAP, and also NAA. As for my study, I'll be using aqueous extract and DPPH from assays for the antioxidant and BAP for the manipulation of in vitro culture. Objectives. Okay, the first one is to investigate the effect of PGR on shoot biomass of Orthosiphon Stamineus. The second one is to compare the antioxidant activities of PGR treated Orthosiphon Stamineus extracts using DPPH, FRET, TPC, and TFC assays. And the third one is to synthesize silver nanoparticles from the in vitro culture of Orthosiphon Stamineus. Okay, so as for the first step, the field-grown Orthosiphon Stamineus were grown in vitro by undergoing surface sterilization before it was grown on semi-solid MS medium. The treatment used was 1 until 4 benzyl aminophorine or BAP, and after that, the antioxidant activities, which are DPPH, FRAP, TPC, and TFC, were undergone on the extract of Orthosiphon Stamineus, and this was proceeded to synthesize silver nanoparticles from the extract, and the ideal condition is that high biomass, high FRAP, and low DPPH value of IC50. For antioxidant analysis, it consists of 4 assays, which are FRAP, DPPH, TPC, and TFC. For FRAP analysis, the sample was added with FRAP reagent before it was read at 593 nanometer. As for DPPH, it was read at 517 nanometer. And as for TPC, it was read at 750 nanometer after incubated in the dark for 40 degrees Celsius for 30 minutes. And as for TFC, the sample was read at 415 nanometer. Now we move on to the most crucial part, which is the results. Okay, so what we could see here is the control and BAP treated culture. MSO, which acts as a control, has no PGR or BAP at all. Okay, so as the concentration of BAP increases, the shoot culture becomes less bushy. Okay, so for the treated culture, we could see that the shoot color have started to become lighter and lighter. So as for 1 BAP, the green color is lighter than the control, and 2 until 4 BAP, there's a slight yellowish color in the shoot culture. And as for 3 and 4 BAP, the leaves have become more tapered and have produced the needle-like structure. This is called this phenomenon is called vitrification. So vitrification of shoots could be due to the long exposure of explants to BAP. It increases the cell water potential and result in vitrification. Okay, so this slide shows the number of shoots, shoot length in centimeter, and fresh weight gram for the control and BAP treated culture. So as for the number of shoot or explant, 4 BAP dominated which goes by 15.8 plus minus 0.76. And also for the shoot length, BAP is still dominated, which has the longest shoot length, 6.63 plus minus 2.32. However, for the fresh weight, it could be seen that 3BAP has the highest weight, which is 0.64 plus 0.2 gram. Okay. Okay, this graph shows the DBPH activities of shoot biomass from field-grown and in vitro orthosiphon Stamineus. So in DBPH assay, ascorbic acid is used as the reference chemical. Field-grown, control, and BAP-treated shoot cultures. Antioxidant activities are tested by using DBPH assay. So the red arrow actually shows the IC50 value. So why IC50? Because IC50 is taken due to complete reaction may not reach in reasonable time. So the lower the IC50 value, the higher the antioxidant potential. So from this graph, it could be seen that 4BAP has the lowest IC50 value, which indicates the highest antioxidant potential compared to the other four. Okay, for FRAP activities, the higher the value, the better the antioxidant potential. So from this, it is deduced that 4BAP has the highest FRAP value, which is 7,200 plus minus 0.0103.02. Okay, this is the result for total phenolic content assay for the in vitro extract of the control and the treated culture of 1BAP until 4BAP. It could be seen here that 1BAP has the highest phenolic content, which is 17.05. However, it is not tally with the FRAP and DBPH assays. This may be due to the extraction method because phenolic compounds consist of polar and non-polar components, which makes them favorable to be to soluble more in acetone or ethanol compared to water. Okay, this is total phenolic content for the control and the treated culture of 1 to 4 BAP of Orthosiphon Stamineus. It could be seen that 4 BAP has the highest total phenolic content, which is 10.13. Okay, so this is a synthesis of silver nanoparticles from the extract of Orthosiphon Stamineus that was grown in vitro. And it could be seen that the formation of silver nanoparticles happen in between 430 until 440 nanometer. However, at the 24th hour, the formation of silver nanoparticles agglomerated, and this may be due to the lack of component in Orthosiphon Stamineus to be the stabilizing agent for the silver nanoparticles. Okay, so as for the summary of the findings, it is suggested that 4BAP has the best shade biomass and has the best antioxidant potential. Okay, for the conclusion of findings, 4BAP producing highest number of shoots has the highest antioxidant activities. Even though morphologically the shoots produced are vitrified, they still have high potential for antioxidant activities. UV visible spectrum of the aqueous in vitro extract of Orthosiphon Stamineus containing silver nanoparticles showed absorption peak at around 430 nanometer. The extract of Orthosiphon Stamineus may contain compounds that act as reducing agent to reduce silver ion to silver. However, it may lack um, the compounds that act as stabilizing agent, uh, causing the silver nanoparticles to agglomerate in the in vitro extract of Orthosiphon Stamineus. Thank you. Thank you.